This MechaFlux Pro 3D tutorial is dedicated to the creation and storage of singular elements in the library. The library is used, as we saw in tutorial number 1, to insert elements into the 3D interface, and therefore into the network, dynamically and quickly. Here, for example, we dragged and dropped a 100 diameter conduit into our network. The singular elements fit into the network in the same way. Here, for example, we can drag and drop a diaphragm into the network, after having selected the element on which we want it to be grafted. Here is the diaphragm that was grafted onto our 100 mm conduit. Each time we add an element, we see them added to the network exploration tree. Small tip: by double-clicking on an element in the project tree, you recenter the 3D interface on the selected element. We have seen how to drag and drop singular elements into the network. We are going to see the other functions for the rapid creation of singular elements. There are singular elements, which are regularly found in the networks. These singular elements are cones, elbows, separation or junction fittings, and valves. MechaFlux Pro 3D therefore has a tool for quickly creating these common elements. Let's see how to access these singular element creation tools. We select an element in the network with a right mouse click. This opens the contextual menu where you can see the different tools available for this element. We see here, for example, the function shrink, which allows to add a converging cone, or expand, which allows to add a divergent cone. We can create a separation at 90, 135, 45 degrees. These angles are defined by default, but can then be modified with Adjust menu. We can create an elbow, or create a valve. We will now detail these different tools. We take for example the cone creation menu. So I click on Expand. This opens the cone creation window. I clicked on Maximize, so the window offers me a diameter twice the diameter of the currently selected element. So here the duct is 100 mm. The proposed outlet diameter is therefore 200 mm. We can apply 300 mm if we prefer. We can set the properties of this cone. We can modify its angle and apply an angle of 10 degrees, for example. We can also set this cone in length. For example, a length of 1000 mm. We can also apply an enlargement sudden from 100 to 300 mm. If I set an exit diameter less than the entry diameter, we will automatically switch to diameter reduction. In the reduction, we can set the angle and apply 10 degrees. A small diagram is superimposed on the diagram of the cone, and this diagram shows the angle formed by the cone. So that's it for this tool for creating taper, sharp shrink, and sharp widen. To insert the element in the section, just click on Insert. We will create a 200 mm diverging cone with an angle of 10 degrees. So for the cones, we can determine the roughness. In the roughness menu, we have a roughness selection aid. We can use a list of materials to determine the roughness. We can therefore insert this cone and also insert the cone and extend it with a duct. This saves a little time information for enlargements, we know that the pressure drops of divergent cones, whose angle is greater at 50 degrees, cause detachments on their wall, and pressure drops, which are identical to a sudden widening. So when you select an angle greater than 50 degrees, Mackay Flux automatically applies a sudden widening. We apply our angle of 10 degrees, and we insert the divergent cone by extending it with a duct, so of diameter 200. Here we have created our singular element, cone, and a duct. We are now going to see, for example, another usual singular element. I double-click on the conduit in the project tree to position myself at its exit, and right-click to open the contextual menu. We go to the Create a Separation menu. This menu allows you to create a parting fitting of a given angle. We are going to create a parting fitting at 135 degrees. A singular separation fitting element has therefore been added at the end of the duct. We see in the tree that when you create a split, the chunks split into new chunks. The continuity rule applies, a section cannot change fluid flow. Therefore, a separation of fluid flows implies the creation of new sections. We see that this separation here, a 135-degree start, was determined when inserting the junction. If we want a different parting angle, we use the Adjust Element function to change the angle. Changing the angle updates the split definition. So the separation became a junction or departure at 90 here for this side there. The other branch remained at 135 degrees. We are going to check that the modification is applied correctly. Adjust the element, we are going to make it go straight for this side of the separation. And we see in our tree that the definition of the split is now a 90-degree pass, because our fluid is flowing through and past a 90-degree split. So that's it for the automatic insertion of singular fitting elements. We are now going to see how to insert a singular element of elbow type. We just click on Create a Bend. The bend creation interface appears with the different bend parameters. We can set an elbow with a radius of curvature of twice the diameter, or enter directly a radius of curvature of 400 mm for example. We can also set a sharp angle. We choose here an elbow with a radius of curvature equal to twice its diameter. Before inserting this elbow, we will see another function of this editor. We have in the elbow editor the possibility of creating serpentines by checking the serpentine box and indicating the number of turns and the spacing of the whirls. For example, here, a coil of 300 mm between turns, and therefore the diameter of the coil. We can therefore create a serpentine. So we see in our interface a series of bends adjusted so as to create a serpentine, which will allow us to simulate, for example, the pressure drops of a cooling system in a fluid bath. So here's to the Bend Editor tool. We will now see the Valve Editor. This tool allows you to insert a valve on the outlet of the selected pipe. We set up a ball valve closed at 45 degrees and insert it into the project. We added a ball valve here at the end of the section. So much for the automatic insertion of the different singular elements. We are going to put a small straight conduit to finish this branch. So here we have a pipe with a diameter of 200. We can use MakeFlux, standard version, to export a singular element to MakeFlux Pro 3D. I open, standard MakeFlux. I'm going to create an element in standard MakeFlux, and export it to MakeFlux Pro 3D. Here, we are going to create a diaphragm, with a diameter of 200. Because we were on a diameter of 200 mm in our Pro 3D project, we are setting this diaphragm, with a hole of 20 mm. So for export, we need to enter a fluid flow rate. A flow rate that is unimportant. And we will also choose a fluid, which is also unimportant, because MakeFlux Pro 3D will apply the fluid. And we click on Export to 3D. The window indicates that the export is in progress. We close standard MakeFlux. And MakeFlux Pro 3D indicates that the diaphragm element has been inserted into its library. We will look in the library for the diaphragm element. We slide and deposit the diaphragm on the selected duct. And there you go. Another way to create singular elements is to use the element editor. It is this function, editor of singular elements, which offers numerous possibilities for setting up singular elements using equations with multiple parameters, which deserve a specific tutorial. A special singular element editor tutorial is available on the MakeFlux site. That's it, it's over for this tutorial for creating singular elements with MakeFlux Pro 3D.